continuing with the fact that when a packet is lost, something has to be done in a realistic network. In this module, we are going to look at the event of timeout, and if the timeout does not happen, we need to cancel the timers so that the retransmission does not take place. The usage of timeout using a timer is actually meant for getting closer to the real-world protocols. The well-known example is the stop and wait protocol, or we say the lockstep communication. Here, what happens is, when TIC sends a packet to TOC, it waits till it gets another packet from TOC. If it does not get such a reply, it means that the packet might as well have been lost. Therefore, it is going to retransmit. We are going to look at the working of stop and wait using the files txc8.cc, tictoc8.ned, and the ini file. We need to define a strategy again. Here, using the classical finite state machine model, we are going to look at how exactly we want the protocol to work. On the left-hand side is the TIC state diagram, and on the right side is for the TOC. In TIC, we see that when TIC is in initial state, after 1 second, it is going to send out a packet called TIC-TOC packet. And it is going to move to another state, which is now it is expecting a message from TOC. If TOC does not reply, TIC is going to time out and it is going to resend the same message. But if TOC replies in time, it means the message arrived event occurs, and correspondingly TIC has to cancel the timer, restart the timer, and send another message. On the TOC side, TOC is on the receiving mode. So, to begin with, if a packet comes and it has a loss probability of greater than 0.1, it means the packet will be lost and this TOC is not going to do anything. So TIC is going to retransmit. If the packet arrives and the loss probability is such that it is less than 0.1, it means the packet would not be lost. And then TOC is going to receive it. It is going to echo it back. When it echoes it back, TIC is going to receive the message in time, and as I said earlier, it is going to cancel the timer. Now, if you look at txc8.cc code, we see that when we initialize, the timeout interval is given to be 1 second, so that the initialization process starts without randomness. Subsequently, here we see that if the message of timeout event is true, it means the timeout has taken place. It means we have to resend it. So the message that is going to be displayed is the timeout expired and TIC is going to resend and restart the timer once again. And certainly here in the lower part of the code, we see that the event is sent out by using a random timer value. Continuing, if we look at the TIC side where it does receive the message from the TOC side, it means that it's a good news. So it has to delete the received message and cancel the timeout event. And you can see that the information is displayed that the timer is cancelled. Now TIC is in a position to send out another packet. This is the visualization in TK environment. Here we see that when TOC receives the packet, it loses the packet with some probability. Here we assumed that the probability of loss is 10%. Here you can also see that the message that is being sent from TIC to TOC and from TOC to TIC carries the name itself.